we're going to move into the juice of the Esri Ocean GIS Forum. It's the Tech Plenary. The idea here is to come up with about 6 specific examples of the work you do, everything from seafloor feature extraction to animal telemetry, shoreline delineation, work with MPAs. How about an example of using the R bridge to look at seagrass abundance? And I think we call it downscaling of atmospheric models. So we've got a true met ocean set of demonstrations using released software. You can go home and do this. And to be sure, if you don't scribble all these notes down, these will be recorded. We'll try to have them up in a matter of days, if not just a few weeks, on the Ocean Forum website. So without any further ado, Kevin Butler has sort of arranged the demos with a host of Esri analysts, statisticians, technologists, the best of the best. Take it away, Kevin.
Well, I thought I'd provide just a few words of context before we actually begin the demos by reiterating some of the concepts that Jack Dangerman shared with us at the user conference and some of the things that Chris Capelli shared with us. I love this graphic. Our world is clearly a very big place, and increasingly we're seeing it as a highly integrated system of systems. The atmosphere, the land, subsurface, and the oceans, they're all coupled. And your sciences certainly reflect that. Our world is also a very changing place, and that change is occurring at an alarming rate. We're challenged by growing population, by climate change, by ocean acidification, social conflicts. That list goes on and on. At the same time, the world's also undergoing this massive digital transformation. New technologies like autonomous vehicles, the Internet of Things, big data, machine learning, they're all changing the technology landscape. And very dynamic and large data sets are coming at us at a greater velocity, and they provide new challenges for data management and for analysis. All of these factors have really contributed to a transformation in science. Just as one example, think about the publishing cycle that we've all experienced. The time scale for proposing, developing, reporting, and publishing our work has decreased from years, at least when I started doing science. It's decreased now to a period of months or even weeks. And we're also in a different political landscape. Political and funding challenges are sometimes pulling us away from doing pure science, primary science, and directing us more towards applied science that's at least perceived to be relevant, more relevant to society and able to generate immediate economic value. So we are indeed conducting science in very challenging times. But there's also a positive side to all of this. We're also conducting science in an era of unprecedented computing power, unprecedented availability of authoritative global data sets, unprecedented means for collaborating and sharing scientific results. So I think this brings really great opportunity. I believe that the science of where is really key to helping us overcome the challenges we're facing, and that it's key to helping us embrace the opportunities before us. So Chris was very clear yesterday in his opening remarks. Our goal at Esri is to help you do your science. From a product development perspective, that means that our goal is to provide you with a rich set of data, tools, apps, ready-to-use solutions and services, really a complete platform that can be combined in creative and scientifically robust ways that help you address the real-world challenges our world's facing. So this morning, we'd like to share 6 examples of this. A few examples of applying the science of where in the oceans and atmosphere. So this morning, we'll literally take a journey. We'll begin at the coast. We'll move to the ocean surface, we'll plunge to the seafloor, and then ascend back up into the atmosphere to highlight some of the powerful analytical capabilities of ArcGIS Pro. We'll begin at the ocean's edge, where Keith Van Graffeland from the Living Atlas team will show us a workflow for semi-automatically delineating shorelines. Over to you, Keith.